Hi there. Today we are going to take a look at completing the square, which is a method of solving quadratic equations. All right, so let's take a look at this example right here. Let's have f of x equals x squared minus 6x plus 4. Now, for the most part, I would only advise using this method when a is equal to 1 and b is even, because if a is not equal to 1 and b is not even, then you run the risk of working with some very large and complex fractions. If that is the case, I would suggest trying out the quadratic formula, which would probably be an easier method for working. But when we have a is equal to 1 and b is an even number, then this is actually a fairly straightforward method. It's also helpful because it can be used to solve problems that can't be factored. This problem right here cannot be factored, and so we have to use an additional method in order to solve this out. Because if we were to try and multiply 1 times by 4, that would give us 4. Well, the only factors of 4 are 1 and 4, and 2 and 2. And neither of these pairs is going to add up to this -6 right here. So factoring is not going to work for this problem. And so we are going to see how we solve this problem using completing the square here. So like all of the other problems we've seen before, the first thing we want to do is we want to turn the left-hand side into a 0. So if you have f of x, or if you have y or g of x, whatever happens to be over here, we're going to change this side into a 0. We're going to keep x squared the same. We're going to keep -6 the same. But then we're going to move this plus 4. We're going to move it out to the side a little bit. It's still part of our equation, but we're going to need to put something else in here in order to make this work. So in order for this problem to be completed with completing the square, what we need to create is we need to create what's called a perfect square trinomial. So we need to make 3 terms right here that will factor into 2 of the exact same parentheses. And so the way that we do that is we're going to take whatever our b value is right here, and we're going to divide by 2, and then we are going to square it. So we're going to have b divided by 2 in parentheses squared. So in our case here, b is going to be -6. The divided by 2 will always stay the same, and the power of 2 will always stay the same for this portion. Well, -6 divided by 2 is going to give us -3. And then -3 squared, -3 times by -3 is going to be +9. So that means I want to take this +9 right here, and I want to add it to both sides of my equation. So I'm going to have +9 right here and +9 over here. Now, the reason that I moved this 4 over to the side is because I don't actually want to combine these together. That would end up making more work for myself, and I'll show you what I mean. So I'm now going to have 9 on the left side, and I'm going to have x squared minus 6x plus 9. And I'm still going to have this plus 4 right here. But I'm going to put these first 3 terms, I'm going to put those in parentheses here because that's our trinomial. That's our perfect square trinomial. That's the portion that's going to get factored. And if you want to see a detailed example of how we factor this out, I will include a link to the video as well. But when we factor this out, this is going to get factored into 2 of the exact same parentheses. Specifically, this number that we had right here, this -3, is going to be the number that's inside the parentheses with the x. So this is going to become x minus 3 in parentheses squared. The whole purpose for us doing this over here is to make sure that this does work out the way that we want it to, that it does end up as this number inside the parentheses with the x right here. Everything else is going to stay the same for the moment. So we're still going to have the 9 over here on the left side. We're still going to have the +4 over here on the right side. Now our equation is actually in vertex form. And so we can solve this just like the problems that we've seen that are in vertex form. So I'm going to cancel out the numbers that are any numbers that are outside of the parentheses on the right-hand side of my equation. So this +4 right here, I'm going to subtract 4 on both sides. And so 9 minus 4 is going to give us +5, and that's going to equal x minus 3 squared. As we've seen with vertex form before, in order to continue solving this, we need to square root both sides of our equation. So our numbers right now are going to stay the same. I'm still going to have 5. I'm still going to have equals parentheses x minus 3 quantity squared. But now I'm going to have the square root of the left side and the square root of the right side. When I do this, I will want to make sure that I take both the positive and the negative roots here. And we've seen examples before of how we simplify square roots. Once again, I will link that video here. But when we do this, for this particular problem, the square root of 5 is just going to stay exactly the same. So the positive and negative 5 is going to stay the same. And then on the right-hand side, I'm going to have x minus 3. Once we have simplified any square roots, once we have worked that out or come out with a whole number here, we want to split this into two equations, one with both the positive square root of 5 and then one with the negative square root of 5. So we want to finish solving these out. We want to get the x's by themselves, which means we need to cancel the 3's that are on the right-hand side. For both of these, I'll be adding 3 on both sides of my equation. Now for this particular problem, we see that the square root of 5 and the positive 3 here are not like terms. So we can't actually add those together. We can't actually combine those. However, if they were both whole numbers or both have the same square roots, if they were like terms, then you would actually want to combine those. But for what we have right here, since they are not like terms, we're just going to write these out side by side. So the 3 is positive, and on this side here, we also have positive square root of 5. So I have 3 plus the square root of 5. And over here, I have a positive 3 once again. But this time my square root of 5 is negative, so it's 3 minus the square root of 5. So there you have it. We've come up with our solutions here. We see that both of our solutions have square roots involved with them, and we will see that from time to time. And that is one of the reasons why this method can be used for problems that can't be factored, is because we can find those square roots as solutions here.